Let us start a new topic today, that is straight line. Straight line. Now we have studied about coordinate geometry already in class 10th, right? So we will extend the discussion of coordinate geometry and talk about straight lines in this chapter. All right, which is the simplest geometric figure. Now to start with the straight line, let us learn a term called slope. Okay, and to learn about slope, let us know what is inclination. Now if we have got this coordinate axis, okay, and let us say there is a line, there is a straight line that we are talking about here. This is line L that I will be talking about, and it makes an angle theta with this x-axis, okay, and it will make another angle with the x-axis that will be 180 minus theta, right? This supplementary angle with the x-axis, these two angles are supplementary, right? So this angle that the line makes with the positive direction of x-axis in anti-clockwise sense is known as angle of inclination. So what is angle of inclination? Angle of inclination is the angle made by the straight line with positive direction of x-axis in anti-clockwise sense. Okay, so here in this diagram the angle of inclination is theta. All right, now what is slope? Slope of a line is just the tan of the angle that this line makes with the positive direction of x-axis in anti-clockwise sense. That is tan of angle of inclination. So the slope of this line L is tan theta, and slope is also denoted by the letter m. So m is equal to tan theta for this line. Okay, now what about some special lines like vertical lines and horizontal lines? Now see, if let us say we have got this line which is parallel to x-axis, right? These lines which are parallel to x-axis. So for lines parallel to x-axis, tan of theta, now this line doesn't intersect with the x-axis, right? Or in other terms we can say this line makes an angle of 0 degree with the positive direction of x-axis, right? So tan of 0 is 0. That means slope of the lines parallel to x-axis, slope of the lines parallel to x-axis is 0. And what is the slope of x-axis itself? It is also 0, right? So what about vertical lines? What about vertical lines? Or you can say the lines parallel to y-axis, lines parallel to y-axis. Now lines parallel to y-axis will make an angle of 90 degrees with the x-axis. So all such lines, right, these are also called vertical lines, right? So vertical lines will have the slope not defined. Tan of 90 is not defined, right? Tan of 90 degrees is not defined. So we will say that slope of the vertical lines is not defined. These lines do exist, right? There are these lines. We do have equations for such lines, but the slopes of these lines do not exist or are not defined, right? So this was a brief introduction about slope. Now let us say if I am given 2 points on a line. Let us say I've got this coordinate axis and I've got a straight line, and on this straight line I know about these 2 points. Let us say these points are x1 y1 and x2 y2. Okay, so if I drop a perpendicular on the x-axis from this point, this is x, this is x dash, this is y, this is y dash, right? And if I drop a perpendicular from this point, now if I join this point with this line by drawing this line parallel to x-axis, so it will be perpendicular to this line, right? So if I ask you what will be this length, we have already studied about it in coordinate geometry that this will be x2 minus x1, because this segment has got length x2, and up to this point this is the length x1. So this is x2 minus x1, and similarly we know that this is y2 minus y1. Okay, and this line here, this line in question, line L, makes an angle of inclination theta, right? So what will be this angle? Now this line and this line are parallel, so this angle will also be theta, because this is the corresponding angle. Now tan of this angle is going to give me the slope of line L. So what will be tan of theta? Let us look at it in this triangle. Tan of theta is opposite by adjacent, that is y2 minus y1 divided by x2 minus x1. So this is the slope of a line when 2 points on that line are given to us, right? Now this was a line making an angle which was acute with the positive direction of x-axis. We may have a situation when this line, because there can be another scenario. Let us say I've got this coordinate axis, right? And this is the line that I'm talking about this time. Okay, so this is my line L, and this angle that this line makes with the positive direction of x-axis is obtuse this time. This is obtuse, right? So what will be this angle here? This will be 180 minus theta, because these two angles are supplementary. These two form a linear pair, right? So now let us see what will be the slope if I am given 2 points. Let us say this point here is x1 y1 and this point is x2 y2. So let me draw these lines and draw this line parallel to x-axis, so it will be perpendicular to it, perpendicular to this line. All right, and now we see that this angle is 180 minus theta. So what will be this angle? This angle will also be 180 minus theta. This angle will also be 180 minus theta. Now we know that tan of 180 minus theta, tan of 180 minus theta is minus tan theta, right? This is what we know, and we also know these lengths. This length here is y1 minus y2, and this side length is x2 minus x1. It is x2 minus x1. All right, now if I want to find tan of 180 minus theta, tan of 180 minus theta will be equal to opposite side, which in this case is y1 minus y2, divided by adjacent side, which is x2 minus x1. Okay, now tan 180 minus theta is minus tan theta, because ultimately I am looking for tan of this angle, which is the angle of inclination. This is the positive direction of x-axis, and this is the angle that this line makes in anti-clockwise direction with the positive direction of x-axis. So I am looking for tan of theta, which will be the slope of this line. So tan of 180 minus theta is minus tan theta, and it is equal to y1 minus y2 divided by x2 minus x1. And now if I multiply both sides by, let us say, minus 1, this negative sign will vanish from the left hand side, and tan theta will be equal to, I will just exchange these, right? So y2 minus y1 divided by x2 minus x1. This is the same expression that we got for tan theta when theta was acute, when the line was making this angle of inclination acute. All right, so slope of a line when 2 points on the line are given is equal to difference of ordinates divided by difference of abscissa. So this is the slope of this line. Okay, so a few things that you should have observed in this are that number one, the line makes an angle in anti-clockwise direction with the positive direction of x-axis. this angle is known as angle of inclination, right? Angle of inclination. So if I rotate this line, let us say, if I keep rotating this line, okay, so when I rotate it after this line, right, this is 180 degrees, it will start making an acute angle with the x-axis once again, right? You can see it yourself. For example, if I go beyond this, let us say, come here, it will again make an acute angle with this positive direction of x-axis. So the angle of inclination that we will talk about in this lecture will be between 0 to 180. So theta will be between 0 to 180 degrees, because this line is going to be the same line as corresponding to 0 degrees. So this was about angle of inclination. And about slope, we said that slope of a line, slope of a horizontal line is 0, and slope of vertical lines is not defined, right? Why? Because tan of 90 degrees is not defined. Also, slope of lines making acute angle with the positive direction of x-axis is positive. Why? Because tan of acute angles is positive. We know that if we talk about these quadrants, right, tan is positive in the first quadrant and is negative in the second quadrant, right? So we can say that for obtuse angles, this slope is negative. Slope is negative for obtuse angles, and for acute angles it is positive. For 90 degrees it is not defined. So for the slope of y-axis, if you say, is not defined, right? Now let us discuss about when the two lines are parallel and when the lines are perpendicular. So let us study about condition of parallelism and perpendicularity. Okay, so let us discuss about parallel lines first. Let us say this is the coordinate axis, and we have got these two lines which are parallel to one another. So let this be line L1, and let us say this is L2. Okay, so these lines are parallel to each other, right? So, and this line, which is nothing but x-axis here, is acting as the transversal. Okay, so let us say the line L1 makes an angle alpha, or let us say alpha 1 with the positive direction of x-axis, and line L2 makes an angle alpha 2 with the positive direction of x-axis. Now what can you say about these angles alpha 1 and alpha 2? As these lines are parallel to each other, right? So because of that, these two angles are corresponding angles, because this is the transversal. Because if I got two parallel lines and a transversal here, so this angle will be equal to this angle, because these are corresponding angles. So these two angles alpha 1 and alpha 2 are definitely equal to each other, right? These are acute angles, so I can say surely that tan of alpha 1 is equal to tan of alpha 2. Okay, so what can I say about the slopes of these two lines? That slopes of, let us say, slope of this line is m1 and slope of this line is m2. So I can say that m1 is equal to m2, and this is the condition for two lines to be parallel to each other, that their slopes should be equal to each other, right? So their slopes are equal to each other. And when the two lines are perpendicular to each other, let us draw a coordinate axis once again. Let this be one of the lines, and let this be another line which is perpendicular to this line. Let us say this is L1 and this is L2, L1 has got slope m1 and L2 has got slope m2. L1, let us say, makes an angle of alpha 1 with the positive direction of x-axis, and L2 makes alpha 2 with the positive direction of x-axis. Now look at this triangle here. What is this angle? This is 90 degrees, right? And alpha 2 is the exterior angle for this triangle and is equal to sum of opposite interior angles, right? So this is the property of a triangle. Alpha 2 is equal to alpha 1 plus 90 degrees. All right. So if I want to have the slope of, let us say, L2, what will be slope of L2? It will be tan alpha 2. And what is tan alpha 2 equal to? It is equal to tan alpha 1 plus 90 degrees, right? And what is tan 90 plus theta? Tan 90 plus theta is nothing but minus cot theta, right? So what can I say about this expression? That it is equal to minus cot alpha 1. Okay, and if I bring it to the left hand side, or cot theta can also be written as, let us say, minus 1 by tan alpha 1. So if I now cross multiply, what will be tan alpha 1 into tan alpha 2? It will be equal to negative 1. What is tan alpha 1? It is slope of line L1, that is m1, and this is slope of line L2, that is m2, and it is equal to negative 1. So the product of slopes of these perpendicular lines, product of their slopes, is equal to minus 1. This is the condition for two lines being perpendicular to each other, that their slopes are negative reciprocals of each other. Their slopes are negative reciprocals of each other, and similarly m2 is equal to minus 1 by m1. So if I know the slope of one line, let us say, if I know the slope of this line is 3 by 4, so what will be slope of this line? This is m1, let us say. So what will be m2? It will be minus 4 by 3, so that the product of these two becomes minus 1. 3 by 4 into minus 4 by 3 will give you minus 1. So if you know the slope of one of the lines and you know that the other line is perpendicular to it, you can immediately tell the slope of other line. And similar is the case with parallel lines. So if I know that L1 is parallel to L2 and L1 has got slope, let us say 1 by 2, so the slope of L2, that is m2, will also be 1 by 2 when I know L1 is parallel to L2. If L1 is perpendicular to L2 and L1 has got slope, let us say minus 5 by 7. Okay, so what will be the slope of L2? It will be equal to 7 by 5, because when I take the product of these two, it should give me negative 1, right? And for lines being parallel, the slopes should be equal to each other. All right, so this was about condition of parallelism and perpendicularity. Now I wanted to find the slope of line passing through 3 minus 2 and 1 comma 4. Let us say I have given you these 2 points A and B, and I wanted to find the slope of this line joining point A and B. So what will be the slope? Slope of AB, or I can say slope of AB, will be equal to y2 minus y1, so 4 minus minus 2 divided by x2 minus x1, that is 1 minus 3. So here I have got 6 in the numerator, and in the denominator I have got minus 2. So the slope of this line will be negative 3, right? Other way of asking a question can be, if I give you angle of inclination of a line as, let us say, 30 degrees, and then what will be the slope of this line which has got angle of inclination as 30 degrees. So I'll say that slope of this line will nothing be but tan of this angle of inclination, so it will be equal to 1 by root 3. Similarly, if angle of inclination is given 60 degrees, slope will be root 3. All right, so this is how we will use this information. Okay, so this was about slope of a line and the conditions of parallelism and perpendicularity.